This video lecture is meant to cover the information found in Unit 9, Section 1 on kinetics, part of the Kinetics, Thermodynamics, and Equilibrium, Unit 9. Kinetics is the study of how fast reactions go, and it turns out that reactions happen not in one step, but usually in many smaller steps. And the slowest of those steps is what was called the rate determining or the rate limiting step. Now, in order for a reaction to happen, the molecules have to collide, but those molecules have to collide successfully or effectively. So effective collisions means that the molecules will collide with enough speed and with the right orientation. That means they have to be moving fast enough and they have to be aligned properly in order for the reaction to actually take place. Now, there are several factors that affect the speed of a reaction. We're going to go through each one of these. Factors that affect the speed of the reaction are catalysts. Catalyst will speed up the reaction by either reducing the total number of steps that it takes to complete the reaction, or it will lower the activation energy, or maybe it'll do both. But the idea is that regardless, a catalyst will do one or the other or both, and therefore it will increase the rate of the reaction. Now, opposite of a catalyst, there are inhibitors. Inhibitors increase the number of steps that a reaction takes to make it happen, or it will raise the activation energy. Either way, there is a decrease in the rate of a reaction when an inhibitor is used. A third factor affecting the speed of reaction is the nature of reactants, meaning they are either ionic or covalent. If the reactants are ionic, they typically happen very fast, especially if they are aqueous. And this is because the bonds are already broken when they are aqueous, so the reaction can happen that much quicker. Covalent reactions tend to be slow because it's harder and it takes time to break those bonds. A fourth thing that you can do is you can change the temperature, which is really a measure of kinetic energy. So the hotter a substance is, the faster the rate of reaction, and this is because there's an increase in the number of collisions, and there's an increase in the speed or the energy of those collisions. Concentration is another factor. Usually it's referred to, the specific type of concentration that we talk about is molarity. With an increase in concentration, with an increase in molarity, there will be an increase in the number of collisions. And that's just because if the solution is more concentrated, you're going to have an increased number of available particles, right? So an increase in concentration will raise the rate of the reaction because it will increase the number of collisions and therefore the number of effective collisions. 6, surface area. If you take a solid and you crush it, you will increase the surface area, which subsequently increases the rate of the reaction because you are increasing the number of collisions. You are exposing more of the interior surface, you're exposing more of the interior particles. So therefore there's going to be more collisions. Now there's another that's not listed on here, and that is stirring. If you stir a reaction, that typically allows the particles to intermingle more, so therefore the reaction will happen faster. Right, so let's take a look at some of these practice questions. 9.1, in a multi-step reaction mechanism, the overall reaction rate is always dependent on, take a look at these, and if you pick the slowest step, then you are correct. Number 2, why does the rate of reaction increase with the addition of a catalyst? A catalyst either takes away the number of steps, shortens the number of steps, or it shortens or lessens the amount of activation energy. So adding a catalyst does nothing to the temperature or the kinetic energy. It does nothing to the concentration of the reactants. It does nothing really to the number of collisions, but what it does do is it reduces the amount of activation energy needed. Number 3, when a piece of copper wire is placed in a silver nitrate solution, the following reaction happens. Which change is not likely to speed up this reaction? Well, stirring the reaction mixture will speed it up, so that is not a correct answer. As will heating the reaction mixture, that will also increase the rate of the reaction. Another one of these choices that will increase the rate of the reaction is increasing the concentration of the silver nitrate. So A, B, and D all increase the speed of the reaction. But using a thicker piece of copper with the same mass really means you are reducing the surface area because you're packing more of the copper into a smaller area. or a larger area, but the exposed surface area is going to be less as a consequence. So a thicker piece of copper, what you'd rather do is use copper powder or copper shaving, something that exposes the most surface area possible. So using the thickest copper wire is actually going to slow down the reaction. All right, that's it for section 9.1 on kinetics. We'll see you in the classroom.